both sides should be presented.
Well, so I'm focused here today on the question of what would you do in the case of severe climate impacts? Because we have to think about this as a risk management problem. And so you're looking for leverage on the system. If you think the impacts are going to unfold relatively slowly, then the array of options with leverage is large, although there's lots of different costs of those. If you think impacts might unfold very quickly, at least under some scenarios, then the array of options is much, much narrower. They might also include, for example, as we argue in the new Bulletin of Atomic Scientists piece, they might include aggressive action on short-lived climate pollutants, because you could very quickly, in emergency mode, cut those rapidly. You might turn off the sulfur scrubbers, you might do a variety of other things and have a quick impact on climate. So it's not the only way to have a quick impact on climate. But I just want to underscore something about timescales. Yeah, it's hard to design aircraft and deploy them and so on, but you can do that relatively quickly, and in fact with modifications of existing aircraft, could get airplanes up, not at the optimal altitude in the stratosphere, but high enough you could start to do a program like this. So when I talk about fast, and I'm talking about being able to do that over a period of, say, 5 years or something like that. Klaus Lochner's idea, which is interesting, and he's one of the most creative geophysicists around. He wants to take the carbon dioxide, which is a low concentration gas in the atmosphere, turn it into silicate rocks, I believe. And he thinks that can be done at $100 a ton. He's got a company that's doing that. David Keith is a company that's got a different kind of approach here. The others have looked at this and think it's a lot more expensive. And scaling it, that's the problem, is how do you intervene quickly at scale? That's the central challenge here. If we could make, in a cost-effective way, any of these sequestration options really work. Trees have the problem that I mentioned about water vapor and about albedo, but if we could make the air capture options work, I don't think at $100 a ton right now, and maybe never because of the thermodynamics, but if we could make them work at scale in a cost-effective way, they're clearly the better thing to do, because they are the perfect inverse of an emission. There's no side effect, because you're having a direct impact on the buildup of the CO2 in the atmosphere of the level of bath water. But if you don't think that can be done, and I would say that the tenor of analysis right now is that cannot be done at low enough costs or scaled quickly enough, then you have to look at these kind of plan Bs, if you like.